Okay, so we'll continue because we only have less than 40 minutes left for the last session, and also for the data visualization. The last session, there will be more codes because we need to do plotting. Then I will just open the notebook we already have prepared. So in the pattern plotting, the data visualization one. So at the beginning, we should import the NumPy pandas if we are going to use them, and also most importantly, the matplotlib. And besides matplotlib, because the most commonly used sublibrary within matplotlib is the pyplot. So we usually just import it separately as a PLT for short. So we just do the importing things at first. Okay, so we have imported. And then because here we are just using an IPython interface or the Jupyter notebook to run all the codes. There are some times that you may also run your codes with a Python kernel or directly through command line or some other IPython interface. Then if you are trying to do a plotting, then this command plt.show will be necessary for you to display the plot. So it will open a new window for you if that's in a terminal or something else. So that will be necessary if that's the case. But for Jupyter Notebook, actually this line of command is not necessary. So Jupyter Notebook actually will render your plotting inline automatically. Yeah. So the first step is to reading the data. And if you are working in the same Jupyter Notebook, then you already reading the data. Or if just as me, I just open this data notebook, then I need to reading the data again. And before we do any plotting, we always want to pre-process the data with so here it's to handle the missing data. So if you take a look at the periodic table, and here for the first plot we want to plot the atomic radius. So if you take a look at the atomic radius column, don't want it to be that large. Okay. Then you will see there are a lot of missing data. So the first step is to drop the missing values in this subset. So we need to run this at first before we do the plotting. Actually, pandas itself provides a built-in plotting method. So we assign the subset as pt_d. So you can use the data frame.plot to directly do the plotting. And that's a very simple plot without enough information added. So we don't have y-axis label, we don't have title for the plotting. And by default, it's plotted as a solid line. And we can change the plotting settings using PLT to add more information and get prettier plots, such as alter the plotting styles, change from line to scatter, or add a title, adjust the axis ranges and labels, and increase the font size, add grid lines, adjust the aspect ratio. A lot of things we can do to get a pretty plotting. So for example, if we want to add X and Y labels, so here we don't have a Y label. So we plot the atomic radius versus atomic number. So the X label will be atomic radius, atomic number, and the Y label will be atomic radius. So we have already added the Y label. Then we can also add a title. We call this plot atomic radius versus atomic number, and also add grid lines. And then that's what we get. So for X label, Y label, title, you can also give it an argument called font size to adjust the font size for the labels. So you may have noticed that I used this for Y label. So that's a special math text because the unit for the atomic radius is angstrom. So I want to type in the angstrom unit here. And sorry, I don't want to use this. So here we just use the text notation to create this angstrom unit. And this is just an example. You don't need to know the codes. But if we just type in, here we just create a figure on the axis for the figure, and then add those 3 lines of text in our figure. And then the first line is just a plain text. We want to say that we have alpha and beta, and alpha is larger than beta. So we just type in this plain text. And then the second line is math text that's used by matplotlib, that you need to place the strings between a pair of $sign. And here we want to have a Greek letter. So for math text, you need to have 2 backslash to specify that this is a Greek letter. That's a little bit different from the text. Here also, you tell it we want a Greek letter for a special character for alpha and beta. So you will have a math text. If you want to do this the same way as how the text doing this, then here we need to put a small r at the beginning before the string, telling it that it's the raw string math text. So in this case, you only need 1 backslash. This can also be used within a similar thing can be used in the Markdown. So for example, you have Markdown, and then you want to type in a mathematical expression, such as an equation x equals to y squared. Then you can get a math expression just using this notation. Okay, so then even though we have this built-in plotting method for pandas, there's much more things we can do with the matplotlib library, which are serving for data visualization. And actually, it's like matplotlib is built based on the NumPy arrays, and it's designed to work well with the SciPy library. And originally, matplotlib, I think it's based on the MATLAB style interface. But there's also another interface later called the object-oriented interface from matplotlib. And we will just quickly introduce both of them here. Let's starting with the MATLAB style interface, and that's why we have imported the pyplot as a matplotlib pyplot, imported it as PLT. And I think that's the most common short form we use for this one. And just call plt.plot function to directly plot dual plotting. And here we want to plot the melting point versus the boiling point. Sorry, the melting point and boiling point versus the atomic number. And so in this case, we want to have 2 lines in a single figure. One is the melting point, versus atomic number, and the second line is the boiling point versus the atomic number. And just as we have done at the beginning, we need to drop the missing data for the two subsets, melting point and boiling point. And after we drop the data, we have less rows in this case. And so although we have this code block here, we'll just keep it below as a reference, but type in those codes one by one. And so at first, we want to create the figure we like to work with. And it takes the parameter fixed size to define the size of the figure. If you run it, then you will get nothing. Sorry. Oh yeah, there is a typo. If you run it, you will get no plots because you just create a plot. There's nothing here. And then we just do the plotting with plot.plot. And it took usually at least it took two input for the x-axis and the y-axis. So here we have dropped the NA value and assign it to a new name PT_MB for periodic table, melting point, boiling point. And the x-axis will be atomic number, while the y-axis being the melting point for the first line. You can just directly run it and you will immediately get a plot. But here, then we can add the second line just by call this function again. We just copy and paste it and change this to boiling point. So you will immediately got two lines in the same figure for melting point and boiling point. But if we show this figure to someone else, then they will not be able to know what's x-axis, what's y-axis, what those two lines correspond to. So we need to add more information to this figure, especially if we want to produce a publication level or quality plot. So I think the first thing is to add the label. So we can do it with plt.x label. And that will be atomic number. And plt.y label. That will be I won't say it will be temperature. In Kelvin. So in this way, we know what x-axis and y-axis is, but still we can't distinguish between those two lines, what they represent. So we want to add a legend of the figure. In that case, we need to label the two lines. The most straightforward way to do this is just to add the label of the lines when we plot it. So for example, here we can label it as melting point. Just copy it. And label this line as boiling point. But we haven't added the legend. So let's use the function from PLT library with legend. Then the two lines will be labeled in this way. And let me see. There are still a lot of things to do. For example, if we don't like the color or if we want different line styles, and we even want the points with marker, that can be achieved by using the keywords here, so you can set the markers, the line type, or the color. So you can set all of those things. But there is a convenient way to do this in a format string form. So we can use some short pattern for that. For example, let me see. Oh, I should do. Yeah, so in this case, actually, this pattern string, this format string stands for O for circle, dash for solid line, R for red. So that's a format string that we can use to specify the color, the line type, the line style, and the marker style. So if we want a different style for the boiling point line, then we can use such as S for square and dash dash for dash line, and say maybe blue, B for blue. In that case, we can tune the how we plot those data. And also, actually, matplotlib handle the limit of the axis automatically, but sometimes we want to zoom in the data or we want to set the limit manually, then we can use xlim, say 0 to 100 to set the range of the x-axis from 0 to 100. Similarly, we can do this with ylim for y-axis. And yeah, here if you're interested, that we provide a link to all the possible format string for the plotting for line style and markers. So you can check it if you're interested. And the exercise or the question here is that I always mention that we need to drop the missing value before we do the plotting. So what if we don't do this? Actually, we can try to plot the data if we without the dropping the missing value. So for example, we can copy the code block here and paste it here for the exercise 1. And then because for this new variable I assigned to, we drop the missing value. So if we use the original data periodic table for all of those x and y axis, so let's zoom in a little bit. So we will see that there will be a break line here. The line will have a gap here because if you check the periodic table for so this line is for melting point. So if you check the periodic table for melting point, then you will see that actually there is a missing value for helium. So that tells us that if you don't drop an A at first, then there will be missing value in your data set. And when you do the plotting, actually the line will be break. So that's something we may need to keep in mind. After we do the plotting, we may want to save the figure. And matplotlib provide a function called save figure to save your figure. We can just run it. And if you check it, the figure will appear here in the same directory as the notebook. And then you will get an empty figure. So that's a feature for PLT interface that actually it always deal with the current state. So as long as we run those codes and the figure already appeared on the screen, then actually the PLT state will be reset to an empty figure. So that's why if we run this, after we have displayed the figure, then we will just get an empty figure. So another way to do this is to do the plotting and then assign a variable to that plot, use the GCF function for get current figure, and then use the method for that object or for the fig variable. So to save the figure in this way. And then if you check the new figure we have saved, then you will get what we want. So that's just something to keep in mind. And you can always explore more for the plot function, just use the help function. So if you want to explore more for plot, yep. And then a simple way to plot 3D data is to just varying the size or the color of the points with z value. So here is an example that if we want to plot how the atomic radius change with periodic and group. So we will set the x-axis as the period and y-axis as their group. So, the x-axis as their group and the y-axis as the period. And then we use the size of the points and the color of the points corresponding to the atomic radius. So here we use plt.scalar for scalar plot, and then have x value group and y value for period, and then we set s for the size to a third value, and the color c for color also to the third value, and then we do the plotting. You will get some nice figure look like this. So it's very similar to how we see an element in a period table, that we have very small elements for hydrogen, helium, and then the elements will get larger and larger along the period, but they will get smaller along the group. So here, interesting thing is that to follow what a periodic table does, actually we put the 0 point for the y-axis at the upper left corner instead of bottom left. So this can be done just simply by switching the minimum and maximum limit for the axis. So for example, here we give the y-lim to specifying we use y-lim to specifying the limit for the y-axis. Instead of put 0 as the start point, we put 0 as the end point. So in that case, because it always follow the style that's starting from the bottom left to upper left. So then although we set a larger value as the start point, in that case it just reverse the axis. Yeah. So that's a very useful way to if we want to reverse the axis. And yeah, so here because I also set the color of the points, and that's also a variable. So we want to add a color bar to show how the color correspond to the size of the atom. Then we just add the color bar by plot.colorbar. And you can also add a label for it. So yeah, that's a quite interesting example for plotting 3D data. And here we only have one panel within the figure. So if you read papers, usually we will have several subplots within one figure. In that case, with plot, it can be done by the method called plot.subplot. And using this method, we can align the columns or rows of the subplots. And this method usually takes 3 integer arguments. If we create, so still start with create the figure with plot.figure and define the figure size to something, say 8 by 4. And then we need to create the subplots using the plot.subplot function. And it takes 3 arguments. The number of rows, we want to put them in the same row. So the number of rows is 1, and we will have 2 columns. Then the number of rows, number of columns is 2. And the index for this subplot, so that's the first subplot. So that's 1. The thing that here is the index for the subplot starting from 1 instead of 0. And then we add this subplot and then plot a scatter maybe for the melting point and atomic number. I will just copy and paste it from the previous plot. Anyway, let's just copy and paste from here. And then if you want, you can also set the label. So for example, here, I just want to set the maybe Y label. You can always set it as you like. Temperature for Kelvin. And then I have added the first plot. And then you can repeat this process to add the second plot and just copy the code and paste it. And now the index will be 2 for the second subplot. And then we change the y-axis to boiling point. And you can also, so now we already got the subplot with the melting point versus atomic number and boiling point versus atomic number in 2 separate subplots but within one figure. There are 2 things here I think we need to pay attention to. The first one is that you will see a line in the output as text, something like this. So that's just the output from the last line here, because we haven't just let it print out the results. Instead, here it will show you at first the result from the last line and then the figure you plot. So if you don't want this, then you can just do it by add a sign, or you can add plot.show. Then it will just show you the figure. Another thing is that you may find there is an overlap of the label from the right-hand panel to the left-hand panel. So that's something that we don't want it to happen. So this can be avoided by add the tightly, I believe it's, yeah, then it will automatically adjust the pad or the layout of the subplots to avoid overlap. Okay, then, so what if we want to change the because for plt.subplot, every time you need to plot everything for the subplot and then move to the second one. You cannot move back, which means that if you want to add a label to the first subplot, then you need to add that lane before you create the second subplot. You cannot do it after you create the second one. That's something related to PLT, because as we mentioned, for the savefig function, that it always deal with a current state. So after you create the second subplot, then the current state moves from the first subplot to the second subplot. So in that case, it's hard or more complicated if you want to move back. So to retrieve the figure at any time you want, we may prefer object-oriented interface, and that works well with those more complicated situations. So here there's an exercise that you can play with it late after the session yourself, and the solutions are included in the all those in the notebook starting with S. And then for the object-oriented interface, we define the object's figure and axis and assign them to a variable. So for example, we can use the equivalent object-oriented command dot add subplot to recreate the plot we show here. And yeah, so that's the step what we're doing. We still need to create the figure at first, and we assign a name to this figure as FIG, and then we add two subplots, and we also assign a name for those axes, and we call them AX1 and AX2 to those two subplots. And then we do the plotting with each object. So we do the plotting for AX1 and set the labels for AX1, and then we do the plotting for AX2 and we set the label for AX2. So for example, here we can just create those two things. We create the figure and axis and add the two subplots. Then you will see two empty subplots. And then we will always be able to get back to those two subplots whenever we want with AX1 and AX2. So we want to plot it's just the same as the plt.subplot that we plot for on the axis 1 with the melting point versus atomic number. So it finished plotting for axis 1, and then we can do the plotting for AX2, and we plot it for AX2, and because it can always get back to the object as we want. So we can set the axis after we plot both of them. We can set the label, so you can always set X label. So it's atomic number. So why we get an error here is that although the main functions plot and scatter are the same for the PLT interface and object-oriented interface, but some of the functions are different, and how we set the label and add title are different. So for PLT, you only need plt.xLabel to add the label for x-axis, and for the object-oriented if we have axis object, then you will need the function set x label. So you just need to add set underscore before the x label. Yeah, in this case, we have set the x label for the first subplot. Then we can always do the same thing for the y label and the x and y labels for the right panel, and we can also add title for them too. I believe it's also set title instead of title. Just call it plot one. Okay, so that's how we do this. And so for subplots, really we do a lot of copy and paste for each of the panel, and that will result in a lot of codes, a lot of lines of codes. So we can also create subplots by just simply use a for loop. So for example, here at first we get a subset from our original data frame with as we introduced in the pandas data frame notebook, that we are only interested in those 3 columns, the atomic number, melting point, and boiling point. So we just get those 3 subset, those 3 columns as a subset, and we can view it. So we only have 3 columns. And then we create the figure before the for loop. So that's the first step. And then we iterate in a for loop with from 1 to 2. So because we have 2 subplot, and then add subplot with 1 row and 2 columns and the index of the figure. So starting from 1 and go through 2. And then we add the plot with the axis dot scatter, and we slice the first column with alloc as the x-axis, and we slice the ith column as the y-axis. So if I is 1, is starting from 1, so if I is 1, then it will be melting point. If I is 2, then it will be boiling point. So then we set x label and y label, and then we can plot. We'll get 2 subplots. So that's a more maybe elegant way to do subplots. Especially here, we only have 2 subplots, then it should be okay. We just copy and paste all of the codes. But if you want to put, say, 4 or 5 subplots in the same plot with very similar things, just iterate it over a list of strings, and then get the subset of the data and use the for loop to do the plotting. So that's a more maybe elegant way to do this. And then alternatively, here we just add subplot 1 by 1, and the subplots can be created in one go using the plt.subplots, and it take mainly 2 arguments: the grid, the number of rows, and number of columns. So here, if we create a matrix of subplots with 2 rows and 2 columns, then you will immediately get 4 subplots with 2 rows and 2 columns. And here, I use share x and share y because sometimes we don't want, we only want x ticks for the for 1 row and y ticks for the left column. So that's why I use this. We can delete it if you don't like it. Then you will have ticks for all of those figures. And then we can always copy and paste the code to add plots for each subplot. And because now we have a matrix and actually the index or the number you gave it will serve as an array. So each plot will be indexed as a two-dimensional array. And for the upper left panel, that's the first plot, and the indexing will be 0, 0, and then this one will be 0, 1, and 1, 0, and 1, 1. So it just works as a two-dimensional array. And we can plot it. So just like this is how it looks like. And we can just copy and paste the codes for all of those remaining plots to create the subplot. But this can also be done by using a for loop. And in this case, we will need two variables. And we define a subset with 5 columns, x-axis, and the first subplot, second subplot, third one, and fourth one. And then define different colors for them and do the plotting in a for loop. Just this is a nested for loop that we have two iterations. So that's how it looks like. And also show you it's shown that how the index for each row and columns go through. And I think we have run out of time, so I will just run this code to show you that we can also do a simple histogram with PLT. So if we want to have a statistics for how many the number of elements discovered every decade, say every decade, between 1700 to 2020, for every year, then we can have a statistics for those of them. And that's how it look like. And you can also customize the bin plot as you want. Okay, so I think that's basic all we want to cover for today. Any questions? Okay, so you're welcome to just play with the notebooks. There are more contents that we haven't covered during the training session. So yeah, please feel free to play with them.